So the last one is case 3. So this is used to determine frictional force. Is used to determine what? Frictional force on a rough inclined plane for upward objects. Case 3, determine frictional force on a what? Rough inclined plane for what? Upward. For upward upward object. Case 3, to determine the frictional force on a rough inclined plane of upward what? Object. Let's check it. Now, assume this is a what? This is the horizontal what? Plane. And then we have inclined plane like this. So the angle between the what? The horizontal plane and inclined plane, let's call the angle what? Angle what? Angle theta. Good. So if I place a body of, this is the body, we place it on what? On this rough inclined what? Inclined plane. Please don't forget that the weight of this body, it will act downward like this. The weight of this body is what? Acting where? Downward, which is what? W. And the reaction of this body, it will acting what? Upward like this. The reaction is what? Is R. Good. But in this sketch, this reaction, you can project a broken line like this to equivalent to this reaction, and this angle of repose here, we can also have it what? Here as angle what? Angle theta. Call it what? Angle what? Angle theta. Good. But there is a particular force here on this what? On this plane, on this block. The weight, the natural weight of what? Of this block is acting downward. Hello? The weight of what? Of this block is acting what? Downward along the what? Along the plane. That one is natural phenomenon. The weight of this block is along the what? Along the plane is this. But the weight of the block on inclined plane along the gravity is what? W. But the weight of the block along the plane is this. So this weight of the block, this one here, is parallel with what? With this line we have here. This line we have here is parallel with what? With the weight here. So from there, the angle we have here is what? Angle 90. Hello? The angle we have here is what? Angle 90. Please, let us remove the triangle outside. By taking the triangle outside like this, we have something like this nature. This is what? The broken line here. Abi? So this is what? This, we call this one what? And don't forget that what? I call this line what? Weight. Abi? And I said this place is what? What? Theta. This theta here is upward, opposite. This place is called what? Adjacent. This is what? My hypotenuse. But my interest is adjacent and what? And opposite. By solving this resolutionally, you will have that what sine theta is equal to the opposite over what hypotenuse. So the sine angle of theta here, what is what opposite here? The opposite here, the hypotenuse. Opposite is unknown. Hypotenuse is what? Is W. So the opposite, it will now be equal to the what? W sine what? Sine theta. Abi? So if this opposite is what? W sine theta and W is what? Is mg. M what? Mg. As a result of that now, this side, it will be what? This side, it will be what? Mg what? Sine what? Sine theta. Good. If this side is mg sine theta, so automatically the weight of the block along the plane, it will be what? Mg sine theta. This is the proof for this. So for every object along the inclined plane, their own weight along the plane is mg sine theta, is the natural weight of the what of the block along the plane. So let us find the what? This side. So by finding this side, let me use what? Cos what? Cos theta equal to the what? Adjacent over hypotenuse. So the cos theta will be what? Adjacent over weight. So the adjacent will be what? Weight cos what? Cos theta. The adjacent will be equal to the what? Mg cos what? Cos theta. So as a result of that, so this side too will be what? Mg cos theta. So therefore, the reaction is mg cos what? Cos theta. Good. That is the what? The resolution of force that takes place for object that is placed on inclined plane. But don't forget, I said for upward object, the body is moving what? Upward. So if body is moving upward, so the applied force, my applied force will be what? Will be here. The applied force P. So we have P is the applied force. So if the applied force is here, and the force, there is particular force again, which oppose the motion of this block along the plane. Hello? This P is applied force that we use to drag the body upward. So if the P is with, that is the acceleration of the body is this A. That is the body is moving up. So when the body is moving up, there is a particular force, which is frictional force, that will oppose the moving of this block upward. And the force is what? Is always downward. So you will now have what? Another force now come from here. And the force that is come from here is what? Is frictional what? Frictional force, Fr. Because its own is what? To oppose the direction of the what? Of motion. This is the force that will drag the block upward. So you can now see that what? In inclined plane, how many forces are we have in the what? On the block? It's three. P, mg sine theta, and the frictional force. P is what? Is the force that will drag the block upward. Mg sine theta is the natural weight of the block along the plane. The third one is frictional force, which is always oppose the motion of the what? Of the block upward. So the next thing is what? How are we going to determine the resultant force? It's the same with what? The case 1 and case 2. Let's check now. Oh yeah, resultant what? Resultant force. Let me demarcate this one out. Resultant force, it will be what? Apply force. Be careful. We have applied force moving like this. Mg sine theta and the frictional force are not the same direction. You are now asked to find the resultant force. So you will what? The applied force is greater than what? The sum of these two. The way we apply is what? In the vector analysis. Check this as a case of study. We have a body like this, a ball. This is what? Force of 200 Newton. Yeah. And here we have force of 50 Newton. We have another force of what? Of 100 what? Newton. We are now asked to find the resultant force. The resultant force will be what? 2 what? 200 Newton minus this are for the same direction. Add them together. They face the same direction. 100 Newton plus 50 what? Newton. They are in the same direction. You add them together. Subtract them from the what? From the bigger force. Apply it here. The applied force is more than what? The sum of md sine theta and the what? Fr. Have you now? So let's go. You now have what? Minus what? What are we going to have now? We have frictional force plus mg sine what? Sine theta. You add them together because they face the same direction. By using that, you now have what? M what? The resultant force. This RF, we know that is what? It's also masked as a what? Acceleration. Abi? So, but with this alone, this is the first method formula for resultant force for object that is being in what? In inclined plane. Change the what? Let me write it clearly. Where what? Resultant force is M what? MA. So for resultant force is MA, what are we going to have? We have MA equal to the what? P minus plus mg sine what? Sine theta. From this expression, our A can be what? P minus Fr plus mg sine theta over what? Over m. This is the what? Resultant, the acceleration of what? But don't forget, this formula, we can also change it furtherly, where we can divide resultant force. Recall, or frictional force, recall that frictional force is mu r. We can put it here. So if you put it there, it will later give us what? As a what? Acceleration applied force mu r plus mg sine what? Theta over what? Over mass. Have you now? This mg mu r mg sine theta. And again, what is what? My r here. Normal reaction. You can also change this and can also change it to what? And frictional force can also give us what? Mu mg cos what? Cos theta. Where do we get it? This r here is mg cos theta from this. So we can put it there. If we insert for it, we have our A should be equal to the applied force mu what? Mg cos theta plus mg sin theta, everything over what? Mass. Let's simplify. We can have what? Is okay like that? Yes. We can simplify to have P what? Mg mu cos theta plus sin what? Theta over what? Mass. This also what? Another way of what? Of divine acceleration. We can divine acceleration in this form. By prove it further, we can also divine it in what? In this form. There are some questions that they will ask you to what? Prove that the acceleration of a moving body in inclined plane, moving upwards in inclined plane of an object is equal to the what? P applied force, mg this cos theta, show the proving. So this is what? The proving. Before we solve question on this, I would like to what? To prove the case what? Case 4 and what? And case 5. So the next case now, I said before we can solve question on this, let me add case 4 and 5. It's like they are look alike. Yes. Case what? Case 4. The case 4 is for downward what object? This is for upward object. The block is moving up. So this time around now, this is our horizontal plane, and this is the with the what? The inclined what? Plane. So the block that we put here, the block is what? Instead of moving up in the case 3, so the block we have here is what? Is going to be what? Moving down. So if the block is moving down with this acceleration what? A. So automatically my apply force, my what? Apply what? Force. Apply what? Force will be this apply what? Force P. We have it here. So the weight, if apply force is what? Is P. It's moving like this. Then the frictional force, which always oppose direction of motion, it will be what? Oppose. You know that what? Frictional force always oppose the motion. The body is moving like this, downward. This is applied force that's dragging it down. The frictional force is what? It will be what? It will be oppose the motion along this line. And the weight, the original weight of this block along the plane, the weight of this block along the plane is still remain what? Mg sin theta. And what? Mg sin what? Sin theta. This is the weight of the block. Like this. So the weight of the block is always what? Down. And the next thing that we need now is what? We have the weight of the block along the gravity is m what? Mg. And here we have what? The reaction of the block should be what? R equal to the what? Mg cos what? Cos theta. Abi? Like the way we did it that time now. So here we have Mg what? Sin what? Sin theta. Or let me use red marker here. Mg what? Mg sin what? Sin theta. And this side is what? Is theta. And this place is what? Mg what? Cos theta, and explain the proof of this here. And the angle of repose is what? Is theta. But the body is moving what? Downward. What will be our what? Resultant force. Resultant force here, you can see that the body is moving downward. Abi? Some of these, mg sin theta and the applied force are more than what? Frictional force. So you now have what? Applied force plus mg sine theta minus frictional force. This will be the what? Resultant force for every object that is coming down along the what? Inclined plane. But lest I forget, note that this surface is what? Is rough. The surface is what? Is rough. This surface is what? Is rough. If the surface is smooth, you will remove frictional force. Please note, oh, this is what? The frictional what? The resultant force. But if we are asked to find acceleration, resultant force will be ma. So you will now have what? Ma equal to the what? Pmg sine theta minus Fr. Our A will be what? P plus mg sine theta Fr over what? M. So this is what? The what? Acceleration. So this is case 4. So let me give you the what? The formula for case what? Case 5 too. Before we now solve question on what? Case 3 and what? And case 4. For case 5, use for static body or body that is about to what? About to move. That's case what? Case 5. Case 3, when the block is moving upward. Case 4 is moving down. Case 5 is what? At rest or about to what? To move. Yeah, let us look at case 5. We have this. We have inclined plane like this. And the angle of repose here is what? Is theta. The block that we place here is what? Is this. But note that what? The block is what? At rest. So this is what? The weight of the block. W, which is mg. The reactant of the reaction of the block, mg cos theta. This side and this side. Note that what? The angle here is what? Angle theta. Good. And the weight of the block along the plane is what? Mg what? Sine theta. And we have what? P here. Apply force P that we apply to the what? To the P that we apply to move the what? The block. But the frictional force which is opposed the motion here is F what? Fr. We can see that what? This diagram is the same thing with the first one here. But don't forget this, the first third one, case 3 is moving up. This one is at what? At rest. You can see that what? There is no acceleration here. Acceleration is here, is moving down. Here is moving up. But here, no what? Acceleration. So the acceleration here is what? Is 0 because the body is what? Is at rest. So we can now have what? Resultant force to be P minus frictional force plus mg sine theta. But note that what? For static what? Body. For static what? Body. For static what? Body. Body is at what? At rest. For that static body at rest, that is acceleration equal to the what? Zero. And where what? Resultant force equal to the what? A. What are you going to have? You will have MA equal to the what? P minus FR plus MG sine theta. What is A stand for? Zero. We have M zero equal to the what? P minus FR plus MG sine theta. By collecting the light types, everything you average is zero. P FR plus MG sine theta. You will now have P equal to the what? FR plus MG sine what? Sine theta. So this is what? The formula for what? When the body is what? At rest. So we can see it now. For the object at rest in a inclined plane, apply for the what? Frictional force plus md sine theta. But note one thing, for all of these three cases, when the what? The plane here is what? Is rough. Abi? But if the plane we have is what? Is a smooth surface, not what? Rough surface. Anywhere you see frictional force, it will become zero. Frictional force will become zero for smooth surface. Please note the case. In case all these planes are what? Are smooth, your frictional force will become what? Will become zero. Please. So let us solve question on these three cases. So let us solve this question 1 to 4 by applying equation what? Case 3, case 4, and case 5. Question 1. A body of mass m is on a point of sliding down a plane, which is at a point at which is inclined at theta to the plane. We just move it up the plane. Good. Mass m on the point of sliding down. On a point, master the point of sliding down. Point of sliding down and sliding down a plane which is inclined at theta. We just move it up. That is, the body is on the inclined plane and is about to slide it down. We are now asked what will be the force that will keep the body to move up up the plane. The thing is very easy. Can I need to draw the diagram? Yes. Let me draw the diagram for question number 1. We are given with angle what? Theta. And this is the body that we have on the what? On the plane. It's about to slide it down. We just move it up the plane. So that is the force that required to keep the body to move up the plane. The weight of the body, normal weight, is mg sine theta. The frictional force is Fr. So these are the three forces we have here. So if you like, you can Show the remaining phase, which is what? Weight. This is normal what? Reaction. If you like, you can show the what? The remaining, but it's not necessary. Our focus on this question now is what? Is about what? To move. This body is what is at rest. It's supposed to be sliding down, but this force keep it. So it's not moving up and it's not moving down. That is, we are now asked what? What will be the force that keep the body to move and not the plane? So what will be our resultant force for the case 5 at rest? Applied force minus frictional force plus mg sin theta. Abi? For the body is at rest, we have what? Ma equals to the what? P minus Fr plus mg sin theta. It's at rest. At what? At rest. The body is at what? At rest. A equal to 0. A equal to the what? 0. And here again, my frictional force is also equal to the what? M mu g cos what? Cos theta. Let's check it directly. The frictional force, we have done it before. Mu mg cos what? Cos theta. Substitute for the each value. If you put 0 here, you have 0 equal to the what? P minus mu mg cos theta plus mg sin theta. And it's equal to the 0. You now have P equal to the what? Mu mg cos what? Cos theta plus mg sin theta. We are looking for the P. We just move it up the plane. So what is what? P. That's what we are looking for. That will allow the body to move up the plane. So if you are having this, you can also say that what? You can also say that recall can also recall that mu equal to the what? Tan what? Tan theta. And then from the trig identity, tan theta is equal to the what? Sin theta over what? Over cos theta. By substitute for what? For mu here, you will have what? P equal to what? Mu is what? Sine over cos, which is tan, abi? Or let me first of all say mu equal to the tan theta mg cos theta plus mg sin theta. But this tan theta is sine over cos. The applied force will be what? Sin theta over what? Cos theta. So will be what? Mg cos theta plus mg sin theta. So in this case now, this cancel this. We are now left with what? P equal to the what? Mg sin theta plus mg sin what? Theta. 1 mg sin theta, 1 mg sin theta. The force that keeps body to move is what? 2 mg sin theta. That will be the final answer. Which of the option is correct? The correct option is what? Is C. So that's for what? For that. Let us look at the second question. Find the force parallel to the slope required to move the body of 2 kg up the what? The slope. You can see that what? The force that move the body up the slope. Again, the applied force is we are looking for here to move the body up the what? The slope. Inclined and static to the horizontal with acceleration of this if the frictional force between the two surfaces is what is this. So here too, we are also looking for what? The force that is make the body to what? To move along the plane, and we are giving what? Acceleration here. So if that be the case, let's solve the second question too. So this is our regular diagram, and this is what is theta, and the body. What is the mass of the body given there? The mass of the body is 2 kg. I mean, the force that is required to move the body along the plane is what? Is P. I mean, now, and the frictional force down the group is what? The frictional force down the group is what? Frictional force is 10 watts, 10 Newton. And here, the weight of the body down is what? Mg sin theta. What is the angle given here? Our angle here is 30. So angle here is what? Is 30 degrees. They give us angle here too as 30, but yes, okay. Here they give us theta. Here is 30. The acceleration. They said the body is what? Moving up. So that is moving up like this. Our A is what? Is 2 meters per second. Good. You are now asked to what? To solve this. How are we going to solve it now? For the P. Apply our formula, regular formula. Our regular formula states that what? Resultant force is equal to the what? Applied force minus frictional force plus mg sin what? Sin theta. So we are given this as 2. So here we have ma should be applied force. Frictional force given is what? Is 10. What is mass? Mass is 2 times 10 sine angle of what? Of 30. Yes, this mass here is 2. It will be 2 multiplied by acceleration, which is 2. Have P equal to what? 10. 0.5 times 20 plus what? Plus 10. Mm-hmm. Yes. Here we have 4. P minus 20. If you go like that, P equal to what? 4 plus what? 20. P equal to what? 24 Newton. That is before we apply what? Force for the question number 2. So let us solve the what? The second what? Question. The third one, a body of mass 2 kg is placed on a rough inclined plane, whose the angle is this. Find the resultant force acting down the slope and the acceleration of the frictional force. Resultant force, then acceleration of what? Of frictional force of 5 between the what? The body and the inclined plane. Let's solve the third question too. We are given question number 3. Let me draw our regular what? Our regular diagram in inclined what? Plane. So what is the mass? The mass given there is 2 what? 2 kg. Abi now, the mass is 2 kg. We have 2 what? 2 kg mass with angle what? 30 degree. Our angle here is what? 30 degree. Then find the resultant force acting down the slope. If the acceleration, and find the resultant force acting down the slope and acceleration of the frictional force 5 Newton. So what is the frictional what? The frictional force, the frictional force that is opposed The motion is what? 5 what? 5 Newton. A body of mass 2 kg placed on the curved plane whose angle of tension is 30 degrees. Find the resultant force acting down the plane and the accelerating of this and the body along the what? So we are given this, and then we know that what? The weight of the body is always mg sine what? Sine theta. So we are asked to find the resultant force and acceleration, but there is a condition here. A body of mass 2 placed on a rough inclined plane whose angle of inclination is 30, find the resultant force acting down the slope. So definitely the body is moving what? Down the what? Is moving down the slope. So it's moving down the slope. The force, the frictional force, this one here supposed to be what? Applied force. And the frictional force we acted what? Up. Where is the frictional force given is what? Is 5 what? 5 Newton. But the applied force is not given here. So we can now say what? The resultant force, wait, what? For down the group, P plus what? Mg sine theta. That is say case 4 minus frictional what? Force. Abi? That's case 4. It's moving down. So you now have what? This one. Resultant force. We are not given P. This RF, the applied force is 0 plus mg, no, and applied force is 0, m is 2, g is 10, sine theta is sine 30 minus frictional force, which is what? 5 Newton. The resultant force is now be what? 0 plus 2 times this is give us 20. Sine 30 is 0.5. So everything minus 5. Here, everything you have here minus 5. We have resultant force to be what? 20 times this, we have 10 minus 5. The resultant force will be 5 Newton. So we are now asked to find the what? Resultant force and the acceleration. If resultant force is what? Is 5 Newton, what will be the acceleration? If the what? Ma equal to the what? 5 Newton. What is mass? 2. 2a over what? The 5. A should be what? 5 over 2. That should be A equal to the what? 2.5 meter per second square. That's the final answer for that one. So let me quickly solve the last one. A mass of 10 kg slide down. A slope of 30 from the rest. The coefficient of frictional force is this. If the length of the slope is 5 meters, find the velocity of the what? Of the slope. Said, let me just use this small space to solve the what? Let me mind this space. To solve the question. This is the body, inclined plane at angle what? 30 degrees. And don't forget that what? We are a body of 10 kg. The mass of the body is 10 what? 10 kg. So coefficient of friction, we are given that what? Coefficient of friction is what? Is 0. What? Is 0.5. Angle theta is 30 degrees, and we are given x, which is what? 5 meters. This x here is the what? Is the distance, the length of what? Of this inclined what? Inclined plane. They said the length is what? Is 5 what? 5 meters. That's x given. They said the body is what? It slides what? It slides down. When the body is slide down, that is, we have m what? Mg sin theta. Then the frictional force is here. There's no apply what? Apply force. You can say that what? Resultant force will be equal to the what? Mg sin theta minus frictional what? Frictional force. So the frictional force is giving the frictional force. Can I say what? Resultant force should be Mg sin theta minus mu Mg cos what? Cos theta. Because they don't give us what frictional force, abi? So the resultant force now will be what is mass? 10 multiplied by G, 10 times sin 30 multiplied by what? Mu is 0.5 to multiply by what? 10 multiplied by another 10 times what? Cos 30. Times cos 30. Can now have what? R should be 100 times this, we have 50 minus 10 times this 50, we have 52. Cos 60 is 0.8660, multiply it by 50. Subtract this now. We have resultant force should be 50 minus 43.3. Subtract it. We have resultant force should be 6.7 Newton. Find the velocity of the mass. So the body is what? To find the velocity now, what? That should be, we will now need to apply the kinetics what? Law. Find the velocity of, yes, if the length of the body is this, find the velocity. So to find the velocity, now we can use work done. The force times what? Distance, which is equal to what? Kinetic what? Which is also equal to the kinetic what? Energy. So you can have force. This force, let me say force times distance, equal to the what? Half of mv square. The work done like this, distance of this. So the resultant force will be what? 6 point what? 6.7 multiplied by what is distance? 5 equal to the what? Half multiplied by mass, which is what? 10 v 10 divided by v square. So this one, what is 6.7 multiplied by 5 to give us what? 3.3 0.68, where we have 5 v square. So by this, without this square, so we get 69.68 divided by 5. So this one will give us what? Divided by 5 Give us what? 13.9. V will be what? Square root of 13.9. So the V is equal to what? 3.7 meter per seconds. So that is all about what? The question. So you can solve as much as possible question from your past questions or your textbooks. So let me look at what the case 6 and case 7. It's remaining 4 cases that we are going to want to treat on this frictional analysis.